Thought we were going over another section.
Huh?
Chapter 9.
We're doing all of 9.
Oh, this is all of it?
Like I told you, there's 5 steps. Each section breaks it up into a specific step. And then the last section is like the entire test. Okay.
Alright, guys. Let's take a look at this insanity. So again, so what is the claim? They leave the debt stay the same. So they think that the average debt is still 906. So does that have an equal sign in it? Yes. So it's got to go where?
To the H.
HO. So I was just explaining to somebody asked me a very good question, what the hell does HO stand for really? And it stands for something called the null hypothesis. Null. Null meaning no. So that one represents the idea that nothing has changed. I always call it the stick in the mud hypothesis. Right? The old man in the coffee shop is like, hey, still the same as he used to be. And then the other one, everything's different with he talks. So that's the one that's the stick in the mud. It's the same. That's why it always has an equal sign. So real quick, a lightning round of stuff here. What if my claim was, let's say the claim was it's at least 11. Would that be the HO or the H1?
The HO.
Why the HO? That's a freaking equal sign. It's just that simple. That simple. Because then I could show evidence for this. What would this one have to be then?
Less than.
And I can show evidence for that, right? If I get a sample that's so far below 11, how far? I don't know. I have to do all the freaking steps. Then that I could show evidence for that. Yes? Oh, well, what if the claim was? If the claim was mu greater than 11? All right, so which one would that be? Why HI?
Because there's no equal sign.
There's no freaking equal sign. So what's the HO?
M is
Less than or equal to. It's got to be the opposite. If neither one has an equal sign, you didn't really do the opposite. Right? Opposite should, together they cover everything, if they're really opposite. Maybe. Okay, so here, where's this one go, of course? HO. So what's H1?
M mu does not equal.
Not equal. So how many tail tests will this be? 2 tail. It's not equal to, you could be greater or less than to show evidence of not equal to, yes.
Can't you always tell by the alpha if it's going to be a 1 tail or 2 tail?
The alpha?
Well, because when you go to look on the T-chart, you use that. I mean,
No, definitely not.
Well,
Alpha could
0.02
be,
is in the 2 tail. That's why
I don't care. I could be feeling really evil and give you a .02 that doesn't show up on the T-chart because you have to use the Z-score chart maybe. Do you see what I'm saying? So, no, don't do that. That's a bad idea. Why is this a 2-tail test? Because the H1 is not equal to. That's the only reason why. Okay, I like it.
Okay. So which one of these do I use? Why a T-score?
Because we don't have a sigma.
Sigma unknown. Okay, that's the second thing you should check.
81's greater than 30.
N equals 81 greater than 30. That's the central limit theorem. Check. Calculator's made up. So we know it's normal enough so we can do something. And since we don't know sigma, we use T-scores. I love it. So rejection region. Degrees of freedom is 80. Alpha is 0.02. It's a 2-tail. That's what I need to know to figure out the T-scores. So I'm going to look at 0.02, 2 tails, stop at 80. You get 2374. Is that what you guys use? Shade out here. So if T star is greater than this or less than the negative this, then we can reject. We always say the same thing. The rejection region always means the same thing. Reject the null, support the high. Why does that make sense? The null is a dude that thinks it's in here. So if I get out here, it looks like the null's wrong. Period. Period. Yes?
When you put it into words up there, does it matter if you put T star is less than before you write greater than?
Of course not. You just got to say both things. Yeah. I like it. So what do I know from the sample? X bar is 82.34. N is 81. S is
107.9.
107.95. So change that. $11.994.
Yes.
Okay. So that's your standard stuff that you do on step D, and now you can make a T-score. I'm going to do this because I don't want to give anything away. You understand? Because if I always said the right thing down here, then you're like, oh, I know what to use. No, screw that. I'm going to say Z star or T star, whichever one. But the formula is the same anyway. Who gives a shit? Right? It's going to be my data minus the middle, and we're just saying, assume the middle's 906. Let's see what happens. Divided by the new standard deviation. What do you guys get? Sounds familiar? Now notice, I'm never going to ask you to get a p-value for a t-score, because the t-score chart, I'd have to make a z-score kind of equivalent chart for every degree of freedom if you wanted to be able to get the p-value. I'm never going to ask you for a p-value for a t-score. Blah, blah. With technology, you would get it. Do I give a shit? No. Because what's the point of this class? Get you to understand the ideas. Once you're out of here, you got to do it for real. You're going to be using software, whatever the shit. Yes?
So say we did, and it was a z-score instead of a t-score, you wanted the p-value.
Yeah, so in this case, I would look up negative 1.97. And now, what's interesting about this problem is, and we will see this tomorrow, since this is a two-tailed test, if I look up negative 1.97, that's my t-star, right?
Yeah.
But then I double it to make it fair, because it's a two-tailed test. So we're going to see that tomorrow. I'm going to focus a little more on that kind of thing tomorrow. Don't quite get there yet. Wait till tomorrow. So what does that mean? Negative 1.97. Did we make it? Did we make it? No. So we failed. We failed to do everything. We failed to reject the null. Failed to support the high. Let me see if you guys get this. Am I sad that we failed? What was my claim? Which one was my claim? HO or H1? Which one? HO. And what did we just do? We failed to reject what I thought was true. I'm happy. Yes. So that fail word just means the test failed. I'm happy. It's like getting a negative test result going, it's negative? Oh, but no, it's negative. Is you're okay? Right? We failed. I'm happy because I don't want to reject the hoe because that's what I believe. That didn't come out right, but my dean is going to be like, I'm watching some of your videos, Jeff. What the shit's going on? So which wording am I going to use? Why? Because the hoe is the claim, that's why, right? So that's always the, people sort of get the steps, and then they're like, how do I word this thing? And they just kind of randomly choose words to throw at me, barf up at me. Whatever your claim is, you word it using the words related to that thing. So which one relates to the hoe? This one does. So fail translates into we have not found evidence. You have not found sufficient evidence to reject the
Claim that the average
Claim.
credit card did it for college students is that.
that, where to go? Mean credit card debt for college students that stay the same. Can you translate that into English for me? What does it look like is true? But the mean is still like about 906, or we're not able to say it isn't. So just to say it really quickly, it looks like it's still 906.
So you could put just the 906. I just wrote the number.
Say again?
So I just put the actual number.
You put the what?
I just put the number.
Yeah, sure. Any variation on this that still makes physical sense is fine. It doesn't have to be exactly what I just wrote. You could use the 906 number if you want to. We have not found evidence to reject the claim that the credit card debt is $906. Beautiful. Now watch this. Does that mean that the credit card debt is 906? We don't know. That's why we never accept the null hypothesis. Let me say it like that. We never accept the null hypothesis because I can't ever prove equality using a sample. I'm hoping this makes some sense. I take a sample, I get the mean. I don't know what the hell the real mean is. But if that mean is really far from 80, then more than likely the real mean isn't 80. I can say that. I can always show evidence that it's not something, but I can never prove that it is something. That's why we use the words that we do. It captures that idea. This is my hopeful Tai Chi. I know this is exceptionally freaky, but it isn't. It's kind of like taking a lot of what we've already done and putting it into one problem, which I know students hate. The minute there's more than 2 steps, you're like, oh shit. There's 5 steps, not that horrible. Remember, in the homework, it's going to ask you to use a certain worksheet in the back. Screw that. You do these steps, these 5 steps. They do it based on doing all of it in the calculator. You should know me by now. That's not good enough for me. Let's learn stuff. Do these, and you actually answer all the same questions they do, just in a better order. Okay, maybe. Yes?
For tomorrow, because the quiz you're going to give us has like all those numbers and everything, how do I find the standard deviation for that if you don't give it without using a calculator?
All right, the quiz tomorrow is on chapter 8. So I might give you one where I give you a list of data, just like today's, the handout we did first thing, right? And you have to make a confidence interval. You with me? So what's the question? How you find
There's no
the
standard deviation in those. We had to find it with the calculator.
Yeah,
but
exactly.
I just forget how to find it manually. There's no way to find it.
No, if you want to do it manually, you do the x minus x bar squared, and you sum x minus x bar squared divided by n minus 1. Remember that? That's what we did for test 1. I'm not going to make you do that again. That was just for test 1 and for homework 2.7, which a lot of you guys said the textbook said to use a calculator. I don't give a shit. You know me. Calculator ain't good enough. All right. So again, on tomorrow's quiz, I will put the formulas on the quiz. And then tomorrow, part of what we'll do tomorrow is do the formula sheet. I'll have the answer key for the practice test. I'm trying to wrap it up and let us out early again. Is that all right? I think we've done enough.
Since we're done, do you usually do it?
Oh, yeah. Can you turn the lights back up back there? Thank you.
Just on the calculator. Like I learned yesterday at tutor
Well, I
how to
mean,
do the
all right, let's not do all of this, but wait, look. So you already got stuff in there, right? So whatever you put in there, blah, 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 blah. Then you go to hit stat, calc. You want to calculate something. One variable statistics. And you want to use the stuff in L1. So just enter, calculate. And there's your S.
S of
Or
X.
X bar. Yep.
And that's for the population, and that's for
If
the
it was a
sample.
population, you could use sigma.
Okay.
But these wouldn't be a population, it's a sample, so we have to use S.
But it gives you both anyways?
Because the calculator doesn't know if you put a sample or a population. We know we put a sample in, we better freaking use S. You can't say, oh, give me sigma too. No. It's just give me both because it doesn't know.
Okay, so stat, calc,
One variable statistics. Because we only put one list of data in.
and we're only doing one list, and then it comes out. And then if we're doing 2, we just...
We're not done do 2. Yeah.
Both on the quiz.
Well, on the quicker test, I would give you a sample, not a whole piece of paper. I'll give you a sample, so then you just put the numbers they give you and then do this.
So both the quiz and the test.
Yes, it could be on either one or both or neither. So we'll see.
Okay. Thank you.
Oh, thanks.
I'll get you the calculation.
Okay.
Okay, I have a
Oh, I
question.
guess I.